Hello and hi everyone. Today we are from Group 2. We are going to explain about the Pople basis set explained. So before that, we are going to introduce ourselves. My name is Muhammad Amir Azamuddin bin Abdul Ghaffar. My number is 200238.
Hi, my name is Nurul Batusha Binti Hussein, matric number 204458.
My name is Jaslyn and my matrix number is 204256. So these are the content of our presentations. So the first one is we are going to explain what is the Pople basis set. So Pople basis set is a different convention was adopted by Pople and co-workers. And the second one is the basis set structure is given for the whole molecule rather than a particular of an atom. So generally in basis sets derived by Pople's group, the S and P contractions belonging to the same electron shell.
So how to describe Pople basis set? Pople basis set, the notation for the split valence basis set arising from the group of John Pople is typically X, Y, Z, G. In this case, X represents the number of primitive Gaussian comprising each core atomic orbital basis function. The Y and Z indicate that the valence orbitals are composed of two basis functions each. The first one composed of a linear combination of Y primitive Gaussian function, and the other composed of a linear combination of Z primitive Gaussian functions.
So the next one is these are the type of Pople basis set. So it is contained STO3G, which is minimal basis set, 631G, the Pople's valence double zeta basis set, and also 631G star, 631G star star, and also the others.
So what is split valence basis set? Basis set of this type are called split valence. Basis set as a description of valence orbital are split into two or more basis functions. The non-valence electrons are described by single basis function composed of a contraction of three Gaussian. Each valence electron is described by two basis functions.
So we have continued to the minimal basis set. The most widely used basis set in this group is the STO3G, which is used for large system and for preliminary geometry determination. So the basis set is available for all atoms from hydrogen up to xenon. The n primitive Gaussian orbitals are fitted to a single data time orbital. So the n is originally took the values from 2 to 6, which is integer. So the minimum basis set is where only sufficient orbitals are used to contain all the electrons in the neutral atom. So in the hydrogen atom, only one single orbital is needed, which is 1s1. And for carbon atom, we have 1s2, 2s2, and 2p2. So we need to differentiate the core and valence electron. So for the valence electron is the 1s1 for hydrogen, and for carbon, the valence orbital are 2s2 and 2p2. So and next we have the split valence basis set. So during most molecular bonding, the valence electron will principally take part. So it's common to represent the valence orbital by more than one basis function. So the minimum basis set can already be exact for the gas phase atom at the self-consistent field level of theory. So the next level of additional function to describe the polarization of the density. So we call this polarization function, where the minimal basis set for hydrogen is one function approximating to the 1s orbital. So a simple polarized basis set typically has two s function and one p function, which is px, py, and pz, and this will add flexibility to the basis set and allow molecular orbitals involving the hydrogen atom to be more asymmetric. So another common addition is the diffuse function denoted by the Pople type sets by the plus sign, and if there are two plus sign, it indicates that the diffuse function are also added to light atoms such as hydrogen and helium. So next we have the 321G star, which is the polarization, and if 321G plus plus is the polarization for heavy atoms and hydrogen. Now at the bottom we have the 321 plus G, which is the diffuse function for heavy atoms, and if there are two plus, is the diffuse function for heavy atoms and hydrogen. And next, lastly, we have our roles.
So for me, I'm the one who in charge in part 2 and part 4, and I'm the one who edit the video.
So I'm in charge of part 5 editing as well as submitting the video.
So I'm the one who in charge in part 1 and part 3, and also I will record the video. I think that's all for our presentation. Thank you.